new package. This is our new package. Christmas lights. 2 plastics. Christmas light. Let us open the close. What is the color? Okay. The end, and then the plug 220, and mini controller, control box, made in China, S8 programs, combination in waves, sequential, slow glow, chasing flash, slow fade, twinkle flash, steady on, push button, CL 2019. Let us what is the color of the Christmas light. Let us see the color of the Christmas light. Where is the plug? Plug it to 220. Take color blue. Let us change the control. Again, change the control. Press. Steady on. Flashing. Strobe. Steady. Flasher, steady, flashing. This one did not blinking because the wire is broken. This one, the wire is broken. So half of the lights are not there are some LED that did not blink, just like this one, because of old stock, already corroded LED wire. There is 20k resistor in series, red, black, orange, and with plastic for separation to separate the two lines LED. So it is coated with hard plastic. This one is hard plastic. Now it's working. LED blinks, and after soldering, so I soldered the LED, the pin of the LED. Now it's working. Now with the glue gun, so this is already repaired with glue gun, sealed with glue gun. Let us check the inside of the box. EK04, 8 programs, mini controller. So we have 8 programs, ZL 2019, number, press. Let's get inside. So we have the 3 lines for the LED, and then the 2 lines for the AC, 220 volts AC. Inside, we have the push button SMD type MB110F. That is a bridge type rectifier. 205 resistor. I think this is a current sense resistor, coupling capacitor, and this one 6-pin IC. I think this one is the LED driver sequencer, or a microcontroller in one. 154 resistor, and it is using a, this one is transistor as a driver, LED driver. It is using a transistor as an LED driver. We have the LED. This is the new generation LED. And then the voltage is 3.14 for this blue color. This is a spare LED, and current maximum 20 milliampere without resistor, and 0.062 watts. So you can see here, that is the maximum light LED that this LED can handle. 20 milliampere of current with a voltage of 3.14 for blue LED without resistor. And anode is, let us see the anode, the shorter pin. The anode is the shorter pin to the positive. The smaller, this is smaller lead, or and the cathode is the has a bigger plate. Cathode bigger plate. Anode is smaller, small plate. We have this figure 1 actual board wirings. So this is the actual. Let us see the actual. The actual, same, 5 connections. Then the rectifier, the microcontroller act as a driver and sequencer to the transistor. And this transistor 406 is a high power transistor that act as a driver of the LED, or LED driver, this transistor. Then the capacitor, push button, and then the resistor. And since we have the actual wirings, from the actual wirings we have now the schematic diagram. That is the reverse engineering of these actual wirings. And we also have this LED, the pin out. The smaller plates is the anode and the bigger plate is the cathode. This is the electronic symbol for the anode cathode of the LED. So the small plate is the anode, the big plate is the cathode. Since we have now the schematic diagram, because the reverse engineering of this control board, we can see now the flow of electrons, or the analysis of the circuit. This is now the rectifier, bridge rectifier. So it means 220 input, that is a sine wave, and because we have the bridge rectifier, it will convert this AC waveform or sine wave into direct current, or a flat line direct current, DC, AC to DC. Because of this rectifier, it rectifies or convert the AC 220 volts into high voltage DC. And then we have this coupling capacitor R2, current limiting resistor, not a capacitor, resistor. Capacitor is this coupling capacitor to stabilize this input of the IC. And then we have this pin number 1, we have now this R1 coupling capacitor, or sort of current sense resistor or coupling capacitor to the AC line. The value of 1.4 mega ohms to the pin number 1. Pin number 4, that is the out to the base of the transistor. Pin number 5, out, pin out to the base of the another transistor. Transistor uses 406, high power transistor. And then pin number 6 is the ground. So you can see here, since we have a switch, this IC is capable of since this is a microcontroller, when we press the button or when we press the switch, it will change the blinking pattern or the lights of the light pattern of each LED. There are two sets of LED, the left and the right. And this one is the connection. Whenever there is a current that flows into the base of this transistor, it will turn on the LED. Again here, we need a triggering current also and a base current, base to emitter current, voltage. But while reverse engineering it, there is a why is it that the connection is something like this? The other end of the LED, since we have two pairs of LED connected to the collector of the transistor, the other pair must be connected to the AC line. Okay? So that whenever there is a voltage base to emitter, it will conduct even the diode is in a reverse bias condition, because the AC is capable of flowing back in the current that flows into the AC. If the AC, this is AC, it will turn on the LED. So this one is connected to the one side of the AC, and the other end of the LED. Remember that this is composed of a series LED. I think 50 pairs, 50 pieces. Also here 50 pieces. But here, this end 50 pieces is connected to the plus or the DC. So when there's a voltage base to emitter, it will switch on the transistor, causing the current to flow from positive, this 5 connected to the other end of the LED. Remember that the LED here is in series, 50. We have at least 100 pieces of LED. So this one is AC, this one is for DC. Okay? For the output side of the transistor, the one is DC to turn on this LED, depends on since we're using the microcontroller, every time we press the button, it will change the blinking pattern of the LED. And this one is connected to, since there's a current here, it will conduct or current flows into the collector to emitter. And the LED turns on. This is connected to plus of the DC, high voltage DC, and this one is connected to the AC, since you can see here the diode is in a reverse. But since we have the resistor, there is it prevents from damaging the LED, since there is a reverse voltage due to the alternating current that flows into the collector to emitter of this transistor. Because the other end of this LED, which is 50 pieces LED, is connected to the 1. Remember, this one is connected to 1, to the AC line, and this one is connected to the positive of the DC, high voltage DC. So that every time you press the button, it will change the blinking pattern of the LED. Pin number 6 is grounded. Let us check this one. Plug to 220 volts. They are all working. Same as the other one. All the lights are working. Let us see the inside of the box. Same ZL 2019 press EK04 made in China, 8 programs microcontroller. Same box. Okay, the same. And also the PCB, they are the same. Push button, bridge rectifier, current sense resistor, IC 6-pin sequencer, LED driver, coupling capacitor, and this one also capacitor, current limiting capacitor. Then two, I think this also using the same. So they are the same box, same unit. They are all working. Same. Plug it again. Control.